All right, so get ready to dive into the world of large language models, or LLMs as they're called.
LLMs.
You know, those things, right? And, you sent us a whole bunch of papers on this.
Yeah.
And one of them that I thought was really cool was this model called Llama.
Yeah, Llama is, it's pretty remarkable,
Do
actually.
that. What is that?
So a llama, it's a really good example of how researchers are trying to make these very powerful models, language models, more accessible to, more people.
Oh, wow.
And
So not just like the big companies with all the money.
exactly, that's
Yeah.
amazing.
Yeah.
And one of the really cool things about Llama is that in some tests, it actually outperforms. Llama A13B, which is a 13 billion parameter model, outperforms GPT-3,
Wow.
which is,
Really?
yeah, and it's 10 times smaller.
Wow. It's like saying that a compact car can outperform like a sports car on a racetrack.
That's a great way to put it, yeah.
That's incredible.
Yeah, it really challenges that notion that bigger is always better
Right.
in the world of AI. And what it really comes down to is how they're training it. They're really focused on efficient training and really smart data selection.
Okay.
And crucially, they only used publicly available data,
Okay.
which is a big deal in a field that's often criticized for being a bit of a black box.
So how do they do that? I mean, how, because it seems like everybody's always trying to find some secret sauce, some secret data
Right.
that nobody else has, and that's how they get ahead. So how did they pull that off?
Well, it comes down to really clever techniques
Mm-hmm.
and really understanding how to leverage the data that's out there. And it's really a testament to the fact that you don't always need, these massive secretive data sets to achieve groundbreaking results.
That's a breath of fresh air to hear that.
Yeah.
That's
Yeah.
great.
Absolutely.
So this is like a big deal. This is like, it's changing the game potentially.
It has the potential to be a game changer. Yeah. Democratizing AI research
Right.
is a hot topic. And this paper is a great example of how it can be done.
That's amazing.
And it gets even more interesting. So, training these massive models usually requires these huge supercomputers, right?
Right.
One of the papers that you sent, 557's Warm Parallelism Training Later.pdf, talks about an alternative approach
Yes.
called swarm parallelism.
Yes. That one. This
Right.
is the one that I was like, what? This sounds like a revolution.
It's a really cool idea.
Yeah.
And it's kind of like instead of having one massive queen bee, you have a whole swarm of bees working together.
That's a great analogy. I like that. Instead of one big supercomputer, it's like having a whole bunch of little, I don't know, worker bees all chipping in.
Exactly. And they
Wow.
can be devices with varying capabilities.
Oh, wow.
So you don't necessarily need the absolute top-of-the-line hardware
Okay.
to contribute to training these models.
So it could be like a laptop working with a gaming PC,
Mhm.
all working together.
Exactly. And that's really powerful because it makes it much more accessible, much more affordable for people to get involved.
That's mind-blowing. It's like turning the whole concept of needing a supercomputer on its head.
Yeah.
That's amazing. So
Yeah.
how does this actually work?
So traditionally, as models get bigger, right, think about the amount of data that needs to be transferred between different parts of the model during training.
Right. It's like more rooms in a house. You need more materials to build the house.
Exactly. It's like building a giant house. You need more materials, more workers, everything.
Yeah.
But this paper throws a curveball with something called the square cube law of distributed training.
The what?
The square cube law.
The square cube law.
Okay, so
That sounds intimidating.
it sounds complicated, but it's actually quite intuitive.
Okay.
So the paper essentially says that as models grow, they might not always need proportionally more resources.
Wait, so it's not always a case of bigger model, bigger headache?
Not necessarily. Not
Yeah.
necessarily. It's like this,
Uh-huh.
imagine your house again, right?
I-
As you make the house bigger, you need more materials. That's a given.
Right.
But the amount of space inside the house, that grows much faster.
Oh, okay.
Right.
Okay.
So you're getting more space for the amount of extra material that you're putting in.
So you're saying with the models, as they get bigger, you're getting more computational power
Potentially. Yeah.
for the amount of communication overhead.
Exactly.
Oh,
And-
it's like the house is so much bigger, the fact that you need a couple extra 2x4s
Exactly.
doesn't really matter.
It's a great way to put it.
Because the house is gigantic.
Exactly. And this is crucial because it challenges a long-standing assumption.
Right?
And it could lead to much more efficient training methods for future LLMs.
It's like a cheat code in a video game. Like you just figured out that you can get way more out of what you already have. That's amazing.
Yeah, it's a really exciting insight.
So I gotta know, how does this swarm parallelism How does it actually work in practice? I mean, it sounds great in theory.
Yeah.
But how do you get all these different computers to work together?
So imagine instead of having, one giant construction crew building that house,
Right.
you have multiple smaller teams, each specializing in different parts of the construction.
Okay.
They can work independently, and then they come together to assemble the final product.
Well, that's cool.
That's kind of the beauty of swarm parallelism. It breaks down this complex problem into smaller, more manageable chunks.
So it's like having, instead of one massive computer, it's like having a network of smaller computers.
Yeah.
And each one is tackling a specific part of the model training. And these computers, again, they could even be different types.
They can be different types, which is another advantage because it means that you're not limited to using, only the most powerful, most expensive hardware.
So it's like a colony of ants, where if one ant can't carry the crumb, the others, they all band together and they get it done.
That's a great analogy. I like that.
And it makes it more resilient. Right.
Exactly.
Because if one of them fails, it's not a big deal.
The whole system doesn't crumble.
The other ants can pick up the slack.
Exactly.
That's amazing.
It's a really fascinating approach.
So this Llama model, you said it was open source.
Yes.
What does that actually mean for, someone like me? Or even someone who's, more technically savvy?
Sure.
What can they actually do with this?
That's where things get really exciting. Being open source means that the code for Llama is freely available for anyone to use, to modify, and even to redistribute.
So it's like instead of just giving somebody a car, you're giving them the blueprints to the car.
That's a great analogy.
And they can tinker with it. You can pop the hood.
Yeah, you're not just interacting with a black box.
Right.
You can actually see how it was built. You can experiment with different training methods. You can even fine-tune it for specific tasks.
So what kind of tasks are we talking about? What could I do with that?
Well, because Llama is a language model, it excels at anything involving text.
Yeah.
So think machine translation. Think writing different kinds of creative content.
Wow.
Answering your questions in an informative way, even summarizing factual topics.
It's like having an army of little AI assistants, and you get to pick and choose which one you want.
And the best part is that this is really just the tip of the iceberg.
Right.
Because as more and more people start experimenting with LlamaK, we're likely to see a whole wave of innovative tools and applications that we can't even imagine yet.
It's like we're just scratching the surface of what's possible.
Yeah.
That's so cool. So we've been talking a lot about making these models more accessible. Okay. But what about making them more efficient?
Yeah.
I mean, training these things still takes a lot of computational power, right?
Absolutely.
Yeah.
And efficiency is a huge focus in AI research. Right.
And the paper you shared on swarm parallelism touches on some really interesting techniques for achieving that.
Oh, okay. Yeah.
And they talk about something called compression-aware architectures, which sounds very jargony.
Compression-aware architectures. That sounds like they're trying to fit, a giant octopus into a little teacup.
Laughter. That's a hilarious image, and it's surprisingly accurate.
Okay.
Because it's all about designing these models to be more communication efficient.
Okay.
Meaning that they can transfer data between different parts of the model using less bandwidth.
So it's not just about the size of the model anymore. It's how efficiently it uses information.
Exactly.
Oh, that's cool.
So they're essentially streamlining the communication pathways within the model itself.
One technique that they discuss using is something called bottleneck layers.
Okay.
Think of them as checkpoints that filter out unnecessary information.
Oh, wow.
Making the model's processing much smoother.
So it's like a super efficient traffic system
inside
the model so you don't have any bottlenecks.
You got it.
That's really cool.
And to take the efficiency game even further, they also explore using something called the max out activation function.
The what?
The max out activation function.
Okay.
And basically, imagine it's like a really strict bouncer at an exclusive club.
Okay.
This function forces the model to select only the most important information to pass on to the next layer.
So it's prioritizing.
Exactly. It's learning to focus on what really matters.
Okay, that's amazing. How much of a difference do these techniques actually make in practice?
So the paper found that using these compression-aware techniques could reduce the bandwidth needed for training by, get this, Up to 4 times.
4 times.
4 times.
That's huge.
It's a significant improvement.
It's like, I don't know, instead of needing a fire hose to water your garden, you just need a watering can. That's a big difference, especially, I mean, because you were saying before about how much computing power this actually takes and the cost involved.
Yeah, this has huge implications for researchers, especially those who might have limited resources.
Yeah, it's a game changer.
Absolutely.
Potentially, yeah.
Wow. It's exciting to think about. It feels like we're on the cusp of something big here.
Yeah.
With AI.
It's a really exciting time. Yeah. But I have to ask,
sure,
with all this talk about, efficiency and accessibility, are there any trade-offs? Is there anything we should be wary of?
That is a crucial question.
Yeah.
And one that researchers are constantly grappling with because there's this delicate balance between pushing the boundaries of what's possible while also ensuring that these powerful models are used responsibly.
Right.
And that leads us to another really important aspect that's highlighted in the research that you sent.
What's this other important aspect? What did I miss?
Well, alongside all this incredible progress, and efficiency and accessibility, the research also really emphasizes the importance of sustainability. It's easy to get caught up in the excitement of what AI can do, but we can't forget about the environmental cost of training these massive models.
That's true, yeah. I mean, we're talking about huge amounts of computing power, which requires energy, lots of it.
Exactly.
So did the research offer any insights on how to actually tackle this?
It did. In fact, the paper on swarm parallelism specifically addresses this.
Okay.
Because remember how we talked about using a network of devices instead of one giant supercomputer?
Right.
Well, that approach could actually significantly reduce the carbon footprint of training these models.
Oh, wow. So it's not just about accessibility.
It's not just about accessibility. It's also about sustainability.
It's about making it greener.
Exactly.
That's fantastic. That's a really elegant solution if it works.
Mm-hmm. Yeah. And it really highlights the potential of this approach to kind of revolutionize the way we think about AI training.
So by distributing the workload, you're cutting down on the energy needed overall.
Exactly. And we can potentially even use devices during their idle times.
Oh, that's cool.
So, when you're not using your computer, it can contribute to training these models.
It's like carpooling for AI.
Laughter.
I like that.
Instead of everybody having their own gas guzzler, we're all sharing one.
We're all sharing resources and reducing emissions in the process.
That's a great way to put it. So it's really encouraging to see that researchers are, they're thinking about this.
Yeah.
They're not just focused on making the biggest, baddest model.
Right.
They're thinking about the environmental impact as well. Mm-hmm. Absolutely. It's about finding solutions that benefit both humanity and the planet.
Right, exactly.
And this is where the open source nature of projects like Llama becomes even more significant.
Okay, how so?
Well, because when researchers openly share their findings, right?
Yeah.
Including their data and their methods,
right,
it allows other people to build upon that work.
Oh, okay.
To replicate their results and potentially to even improve upon them.
So it's like this rising tide lifts all boats kind of situation.
Exactly. It's like the old saying, 2 heads are better than 1, or in this case,
Or a whole swarm of heads.
Exactly.
Yeah.
Exactly. And the more minds we have working on these challenges, the more likely we are to find creative and effective solutions.
Yeah, that makes a lot of sense.
Because, let's face it, the future of AI is not something that's going to be decided in a vacuum.
Right. It affects all of us.
It's a conversation that needs to involve everyone.
It's a conversation that's already happening whether we realize it or not, because it's like...
It's all around us.
Yeah, it's everywhere.
AI is already touching so many aspects of our lives.
Yeah, it's true.
And it's only going to become more prevalent in the years to come.
And what we've talked about today, it's like, it really does feel like we're just at the beginning of something.
Absolutely. We're just scratching the surface.
Of this whole new world.
It's a really exciting time to be involved in AI.
It really is exciting. And, a little bit intimidating.
As well.
I have to say.
A healthy dose of caution is always a good thing.
Yeah, for sure.
But overall, it's a future full of possibilities.
It is. And as we wrap this up, I wanted to say, I do feel a sense of optimism after learning about all of this. Yeah. Because it seemed like we're moving in the right direction.
Yeah, and I think the key takeaway here is that the future of AI is not predetermined.
Right.
It's something that we're all actively shaping.
Yes.
Through the choices that we make.
Right.
The research we support, the conversations we have.
Absolutely. It's in our hands.
Exactly.
Well said. Well said. So, to our listeners out there, we'll leave you with this thought. as you continue to explore this fascinating world of AI.
Yeah.
Remember that you're not just a spectator.
You're not just watching from the sidelines.
You're a participant.
You have a role to play.
Ask questions, stay informed, and never stop exploring.
The future of AI is in your hands.
On that note, we'll sign off for today. Until next time, keep diving deep.